All right, ASChem, here is the last lesson of the year, organic chemistry. And to start off, let me just name a couple things. Organic chemistry is a notoriously difficult subject in chemistry. It is a years-long course at the college level, so there's a lot here that we could do, but I'm only going to give you the basics, what you really need to know, because, and this is the second thing I wanted to tell you, this is an extremely important topic to know for whatever science you're going to take in the future, whether you're going to take AP Environmental Science, AP Bio, AP Chem, College Chem, whatever it is. You need to have a basic understanding of organic chemistry, because organic chemistry is kind of the practical chemistry. It's the chemistry of making things. It's the chemistry of most everything around us. So many of the substances you have around you are organic substances, and so many of the substances you're going to see in the future are organic substances. And so you really need to know how to draw organic substances, how to interpret and understand organic substances and the formulas and names of them. So let's give you guys the basics today in this lesson. Again, just the pure basics. Third thing, though, I do want to mention before we get started is that organic chemistry is somewhat flexible, meaning, you know how like in English or in history, there's kind of more than one right answer sometimes? It's the same thing in organic chemistry. Oftentimes, especially in the answer key, you'll see I write, this is the answer, or this, or this. There's multiple ways to do it. That drives some students crazy, because that's different than a lot of other things in chemistry, where it's like there's only one right answer. Unfortunately, in chemistry, there's, in organic chemistry, for one, there's multiple ways of doing things, as well as there are multiple right answers, or multiple ways of doing the same thing, and showing the same molecule. And so, be patient. Take that as something good, okay? If you get upset about it, this is going to be horrible, okay? Like, if you're like, oh, I want one right answer, and I'm upset that there's multiple answers, I don't like ambiguity, you're going to be miserable. Instead, embrace the fact that it's flexible, that there can be more than one right answer. It doesn't mean that, your wrong answer is right, because there are also multiple wrong answers. But accept and know that there are multiple right answers, okay? So, those are your disclaimers. Before we get into it, let's get into it now. Organic chemistry is the chemistry of organic compounds, but specifically, it's the study of carbon-containing compounds. And so that's its definition. So basically, it's things that have carbon in it. Now, you might be saying, why do we devote an entire kind of section of chemistry, an entire course in chemistry, to just carbon-containing compounds? Why carbon of the 120 elements on the periodic table? Why do we devote so much time to carbon? Why is carbon so important? And the reason why carbon is so important is because, take a look at its structure. You see those lines, right? If we were to draw its Lewis dot structure, it looks something like this, right? And so, what is the thing with carbon? Well, carbon is what I like to call, it's the ultimate Lego piece of sorts. If you think of, our atoms as Lego pieces, as, kind of building blocks, things that we used to build, carbon is the best. It's that one Lego piece that you want, because it's so versatile, because it can connect so many things, because it's really the cornerstone, right? Carbon, remember, it has 4 valence electrons. Remember, carbon has 4, and the goal in life of every atom is to get 8. And so if carbon has 4, it wants to get 8. How many bonds is it going to form? It's going to form 1, 2, 3, 4. It can form 4 bonds. That's more than all the other elements, other than the other group 14 ones, right? But the group 14s, with carbon being the first of the group 14s, can form 4 bonds. This is great, because that's very versatile. Unlike hydrogen, which can only form 1 bond, right? And so it's not really a good connector. Carbon can sit at the center of things. It can connect a ton of things together, right? For example, I can adorn this with, 4 hydrogens, and this is what we call methane. Or I could adorn it instead with just hydrogen. I could put some fluorines on here, right? Or if I want to get fancy with it, I could put an oxygen and then put 2 hydrogens here. Or if I wanted to, I could put a nitrogen and then a hydrogen. Do you see how carbon is at the center of everything? Carbon is a great Lego piece. It's a great connector. This is why it's at the center of all of these compounds. That's why we devote an entire branch of chemistry to studying it. Okay, so that's why carbon is so important. And so at the center of everything, in everything we're making, is going to be carbon. Um, Now, the other thing that you need to know before we get started, so this is what is organic chemistry. It's the study of carbon-containing compounds, and it's because carbon's the ultimate LEGO piece. You also need to know roots. Now, the good news is you already know these guys. You already know what pent and hex mean. Pent, pentagon, right? That means 5. Hex, hexagon, right? We know that that means 6. These ones, though, you aren't as familiar with. And so what I need for you to remember is to just put this in your mind. Meth, eth, prop, but. Repeat that over and over again to yourself as you're walking to class, okay? Promise me the next couple days, you'll just repeat to yourself. Meth, eth, prop, but. Meth, eth, prop, but, right? If you have those 4 memorized in that order, you have everything memorized that you need. So meth, eth, prop, but. Meth, eth, prop, but. Meth, eth, prop, but. 1, 2, 3, 4. 1, 2, 3, 4. Meth, eth, prop, but. By having this memorized, this will allow you to be able to understand the naming of organic chemistry. Okay, so meth, eth, prop, but, those are the roots that are going to help us know how many carbons are involved in our compound. So let me give you some examples. And so as you see, I'm going to go through a study guide because what I really believe is that organic chemistry, as I'm mentioning here, it's really caught, not taught. What I mean by that, caught, is like you have to catch it. You have to just learn by doing it. You're not going to be able to learn it by just trying to memorize some things. You can, and this is why students college hate organic chemistry, because they try to memorize everything. You cannot just memorize organic chemistry. It has to be caught. You have to do it. It cannot be taught. You have to converse. It's like, as I mentioned here, it's like language. You have to do it. You have to. You can't memorize everything in Spanish and then think you're a Spanish speaker, right? That's the problem with things like Duolingo. You have to use Spanish to speak Spanish, right? And so the same thing with organic chemistry. You have to use it in order to know it. And so here, let's see what we do here. So straight chain hydrocarbon. So basically we are going to create compounds which contain carbon and hydrogen. Okay, so carbon and hydrogen containing compounds. Now, how you do this is, you see the name of the hydrocarbon is methane, or methane as the British like to say, but that's gross. Meth, eth, prop, but. Meth is 1. And so what that means is this hydrocarbon has 1 carbon. So this meth tells us, hey, I have 1 carbon. And so how you would do this is I start off with the Lewis structure and I say, okay, I have 1 carbon. Now we know that 1 carbon wants to form 4 bonds. And so the rest of it here is just going to be hydrogens, because hydrocarbons, right? Carbons and hydrogens. And so how am I going to be able to get 4 bonds for hydrogen? Sorry, for carbon. You can see I'm already Freudian slip. I'm giving away the answers. All right. How can we get 4 bonds for carbon? Well, we're going to need 4 hydrogens. Remember, each hydrogen wants 1 bond. And so here, each one of these will form 1 bond with carbon. And now, has carbon formed its 4 bonds? Has it achieved its goal in life? Yes, it has achieved its goal in life, right? So it's happy. Everyone's happy. And so we can now write the formula. We have 1 carbon and 4 hydrogens. And so we have C1H4, but remember, we don't really put 1s as part of the formula. So it's just CH4. And so there you go. Methane is the 1 carbon containing compound. Its formula is CH4. It looks like this. Line drawing we'll get into when we get to ethane. Okay, so that's how you would do it. All right, let's go on to the second one. Ethane, remember meth, eth, prop, but. Eth is 2. And so here we're going to have 2 carbons. Now, always draw the carbons together and having 1 single bond between them, because they have to, right? Otherwise, they're just kind of floating off in distance, and then therefore they're not the same compound. And so, you have to start off with your 2 carbons and have them form 1 bond. Now, the thing is, they form 1 bond, but they each want to form 3 more, right? And so we're going to have hydrogens all around to form those next 3. So here is ethane. It is C2, H1, 2, 3, 4, 5, 6. C2, H6. There you go. I'm going to come back to the line drawing. Okay, let me get to propane, and then you'll start to see the reason why we need line drawings. All right, so meth, eth, prop. 3 carbons. And so propane, we have 3 carbons. We need bonds for the rest of these, and so we're going to put hydrogens all around. And so now we have C3, H1, 2, 3, 4, 5, 6, 7, 8. C3, H8. And there you go. Actually, let me get to butane and then we'll do the line drawings. All right, so bute, meth, eth, pro, bute, 4 carbons. And so 1, 2, 3, 4. All right, now we're gonna put hydrogens all around. Remember, if you ever get confused and at the end you're like, wait, did I draw it right? Just make sure, does every carbon have 4 bonds? Does every hydrogen only have 1 bond? Let's see, this carbon, 1, 2, 3, 4, yep. 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 All right, so everyone is happy. So we have C4H1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. All right, so at this point, if you're following along with me, you will realize that this is getting kind of annoying to draw it all out and draw all these hydrogens. If only there was an easier way to draw this. And so, yeah, chemists are lazy, and so they did figure out an easier way to draw this. The line drawing. Basically, in a line drawing, what you're going to do is you are going to replace the carbons with vertices. Vertices, remember, are just like, for example, if I have a square here, right? This is what we call a vertex. All right, it's like a point as a result of 2 lines coming together, as geometry teachers would say. Right, and so we're going to replace our carbons with vertices. So here, what we're going to do is I'm going to replace this carbon with a vertex. I'm going to replace this carbon with a vertex. I'm going to replace this one and this one. And, you know, we could draw a line, but the problem is if we do it like that, you can't see 4 vertexes. And so what I need to do is I need to draw it instead with angles. And so we're going to do it like this, okay? So 1, 2, that's 2 carbons. And I'm going to put 1 more down here, that's 3, and then 1 more here, that's 4, okay? And so each one of these, right, as you can see, we have 4 vertices, and so that equals to 4 carbons. Now, what about the hydrogens? Well, they're annoying, and so we don't draw them. That's it. That's all you have to do. It's assumed that each one of these has as many carbons as needed in order to make it happy, okay? And so secretly, right, there are these hydrogens, right, because now it has 1, 2, 3, 4. This one would have 2, because now it has 1, 2, 3, 4, right? This one has 2. This one has 2. But we don't draw these because, again, it's annoying, right? It's annoying to draw all that out. And so you can assume that it is. You can draw it out if you want, right, just to make sure and to really see it, but you don't have to. Especially on a test, if it says draw the line drawing, don't draw the hydrogens, okay? You can to, like, make sure, but then erase it like I just did, okay? All right, so how will we do that for propane? Well, propane has 3 carbons, so how many vertices should it have? Well, 3 carbons, 3 vertices, so we're going to get 1, 2, 3. There you go. And that's the line drawing for propane. All right, ethane, how would we do this one? Well, this one's actually really easy. You can just do that. Or you could just draw it like this too, that's okay. So yeah, either way would work. Now here also actually technically, right, you could draw this like this, like that would also be acceptable. This one, you could draw it like, you know, instead of starting off, you can start off like this, right? And so it looks like that, right? And these are the same thing. It wouldn't matter. I would give you the points regardless, right? Because they're showing the same thing. And so, again, I do want you to see that it's okay to do it like that. It's ambiguous, but it's like, that's okay, that's fine. You're following the rules still. There are ways to do it that would be incorrect, okay? So for example, for butane, if you drew something like, I don't know, if you just drew this, right, the way I did it first, right, that's not correct. You can't do that. Or if you do, I don't know, let's say you do that. Well, this has 1, 2, 3, 4, 5 vertices, right? And so that's also not okay. Okay, so don't take what I'm saying about ambiguity to mean you can be wrong. That's not what I'm saying. But what I'm saying is there is multiple ways of doing some of these. Okay, so be okay with that. All right, okay, so continuing on. Pentane, we got 5 C's here, and so it's getting very annoying, but let's do it. I guess there's something oddly satisfying because it's kind of brain dead. But hey, there you go. Pentane, right? Everyone's happy. And so we have 1, 2, 3, 4, 5 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. There you go. All right, how do we do the bond line drawing? Well, 1, 2, 3, 4, 5. There you go. Or again, right, I could do it like that. That's also okay. All right, so yeah, that's pentane, hexane. That's 6 C's. So 1, 2, 3, 4, 5, 6. And so we have C6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. C6H14. There you go. And so now, there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There you go. And that's the chemical formula for hexane. And now, one thing you might have noticed, especially if you like math, is you might have noticed there's a little bit of a pattern here in terms of our formulas for our alkanes. And so we can put it here. What's the general formula for our alkanes? Well, here we have carbon, and then we have it's 1 to 4, the carbon to hydrogen ratio. And here it's 2 to 6, and here it's 3 to 8. And so it's not like a simple, it's not like a 1 to 2 or 2 to 4 ratio. The ratio is changing, but it's based on a formula. It's based on a kind of series formula. And so what we can see here is that basically whatever you have here, just double it and then plus 2. So here, 1 times 2 is 2, plus 2 is 4. Here, 2 times 2 is 4, plus 2 is 6. 3 times 2 is 6, plus 2 is 8. 4 times 2 is 8, plus 2 is 10. 5 times 2 is 10, plus 2 is 12. 6 times 2 is 12, plus 2 is 14. Right? And so what we can write here is the formula is CnH2n plus 2. To get the number of H's, just take the n's times 2 plus 2. Okay? Times 2 plus 2. Right? If n is equal to 5, then that means that the number of H's is, right, so C, n is 5, so H's is 2, 5 plus 2, it'll be 10 plus 2, which is equal to 12, right, and that's what we see here, right, so that's our formula, the general formula, CnH2n plus 2, just take however many carbons you have, times it by 2, plus 2, that gets you the number of H's. All right, so those are your alkanes. Now what we're gonna learn here are alkenes and alkynes. All that means is enes is there's a double bond somewhere. And ynes is there is a triple bond somewhere. And so let's take a look at what that looks like. All right, so ethene, sorry, I keep thinking about the British. They're so cool, such good chemists. But ethene is, it looks like this. Well, we see the formula, I gave it to you because to help you guys learn it. It's C2H4, and so what that looks like is, okay, we have, 2 carbons, and then, we're gonna give each of them 1 hydrogen, or sorry, 2 hydrogens. And so we've used up all our hydrogens. 1, 2, 3, 4, there's 4 hydrogens. And so now what we see is we got 1, 2, 3 bonds for this carbon, so it's not happy. And we got 1, 2, 3 bonds for this carbon, so it's also not happy. And so how can we make it happy? Remember we learned back in November that if you have a bond line, if you have a Lewis structure and our elements still are not happy, what you do is you're gonna form double and triple bonds to satisfy them, right? And so here the hydrogens are happy, but the carbon isn't, and so what we need to do is we need to form a double bond between the carbons. Now, can we do that? We can, right? If I was to really draw this out in depth, right, what we would see is that we basically have had a situation that looks like this at the moment, where we formed a bond here, between the carbons, right? And then we formed a bond here between these hydrogens, but we had left over these 2 electrons. And so what we're going to do is we're basically going to move those in, and we're going to put them here so that the carbons can then share them. And so that's why it's legal. Okay, this is legal. I'm not just making up electrons here. And so now if we do that, carbon has 1, 2, 3, 4, and this has 1, 2, 3, 4. So everyone's actually happy now. Yay. And so this is what ethene looks like. Now if I could draw it for you a little bit more cleanly, what it actually looks like is it's going to look more like this. We draw it more like this. And so, yeah, this is what ethene looks like. Its bond line drawing is very simple. You just do almost like an equal sign. There you go. All right, so that's ethene. Now let's get to ethyne. Ethyne, remember, "-ine" means triple bond. What does that look like? Well, here we have C2H2, and so we're going to draw that. And so we'll give each of these carbons one hydrogen each. But we see here that, yeah, carbon isn't happy. And actually, in fact, right, it has 2 valence electrons each here. And so it has 1, 2, 1, 2. Both of them have 2 bonds. They want to form 2 more. They both have 2 valence electrons to give. And so you can see what's going to happen, right? We're just going to move these over. We're going to move them over in here. And what we're going to get is something that looks like this. And so that's ethyne. Ethyne looks like that. It's bond line drawing. We're just going to draw like this. Sometimes people draw it like this. You don't have to. You don't have to include those hydrogens, but so just to keep it simple for you guys, just draw that. There you go. That's ethyne. Ethyne. All right. So now let's go on. Propene. Propene. Well, remember meth, eth, prop. Prop is 3 carbons. Ene means that there's a double bond. All right, so what will this look like? You got 3 carbons, and